Hello everyone, we want to dive into the world of psychogeometry with this comprehensive video. Whether you are a student studying for exams or a math enthusiast, this video is for you. My name is Brighton and I hope the information in this video will be helpful. I'm going to read the information regarding the question which you want to answer in this video. The line joining A, which has got the coordinates 5, semicolon 3, and B, which has coordinates 4, semicolon minus 2, is a diameter of a circle. If P, which has coordinates X, semicolon Y, is a point on the circumference, find a relationship between X and Y. So this point A, which is 5, 3, and point B, whose coordinates are 4, minus 2, and point P, whose coordinates are X, semicolon Y. So to find a relationship between X and Y, we are going to apply coordinate geometry and a certain circle theorem. So we are going to draw a straight line from B to P and also from A to P, so that the angle APB will be equals to 90 degrees. Since AB is diameter, it means that this one is a semicircle and this other half is a semicircle. And a semicircle subtends an angle of 180 degrees at the center and an angle half that size at the circumference, that is 90 degrees. So angle APB will be 90 degrees. So I'm going to draw the line BP and the line AP so that will form an angle APB, which is equal to 90 degrees. Okay, so this is 90 degrees, and also this is our center here. Remember also that there's a theorem which says that an angle at the center, this one, is 2 times an angle at the circumference. So if this is 90 degrees, this one here at the center is 180 degrees. So angle APB equals 90 degrees because angle at center equals 2 times angle at circumference. Okay, so let's move on with our working. So AP and BP are straight lines and they are perpendicular to each other. There is a property which states that the product of the gradients of perpendicular lines is -1. So we are going to use this property to find the relationship between X and Y. Okay, so if we call the gradient of the line AP M1 and the gradient of the line BP M2, their product will be equal to -1 because there's a property which says the product of the gradients of perpendicular lines is -1. Okay, so the gradient of a line passing through the point A, whose coordinates are, say, x1, y1, and also the same line passing through point B, whose coordinates say x2, y2. Okay, the gradient of the line passing through these 2 points is given by increase in y over increase in x. Okay, we can write it as follows: m standing for gradient equals y2 minus y1 over x2 minus x1. Okay, so we are going to use this equation to find the gradient of line AP and the gradient of line BP. Y2 here is the y coordinate of, say, point B, and y1 is the y coordinate of, say, point A, and the x2 is x coordinate of point B, and x1 will be x coordinate of point A. So we are going to find the gradient of line AP using this equation. M equals y2 minus y1 over x2 minus x1. So we are going to substitute the values here at these points in this equation. Okay, so I'm going to take my y2 as this general y here, so that m equals to y, and my y1 will be 3. So it's 5, sorry, y minus 3 over my x2 again. I'm going to take this one here, this x coordinated p, that will be my x2, and my x1 will be this 5 here. So I mean to say gradient of AP is equal to y minus 3 over x minus 5. Okay, before you go any further, let me mention something which is key to remember here. It doesn't matter in which order you take these coordinates and substitute them in this equation. Okay, I can choose this 3 here, this y coordinated A as my y2, and this y here as my y1, and this x coordinate here, which is 5, is x2, and this one is x1. So the only thing that you must be consistent. If you take y2 from here, from A at A here, you must take also x2 at A. And remember, here we will be using, these ones will be x1 and y1. But if you choose that your x2 and y2 will come from this point, so these ones will be the x1 and y1. Okay, so this is the gradient of AP. It doesn't simplify any further, so we leave it like this. So let us find the gradient of BP. Okay, so to find the gradient of BP, which is a perpendicular line to AP, we also use the same equation. M equals y2 minus y1 over x2 minus x1. This m here stands for gradient, and this one, y2 minus y1, is increase in y, and x2 minus x1 is increase in x. Okay, remember, gradient is just a measure of the slope of a line with respect to the positive x direction. Okay, so to find the gradient of BP, I'm going to take these values, these coordinates, and substitute them in this formula. So my y2, I'm going to take that y at p, and my y1 will be minus 2. So y minus 2. Okay, so be careful here. This minus is for the for the formula which we are using to find gradient. It has nothing to do with this minus sign, which is already on the y coordinate. Okay, so my x again, I'm going to take this one at px minus, and my x1 is this one, 4 here. Finally, we have y minus 2 is y plus 2 over x minus 4. So the gradient of BP does not simplify any further than this. Okay, so now I have the two gradients of the perpendicular lines, and remember, there's a property which says that the product of the gradients of the perpendicular lines equals 2 minus 1. So we are going to use that property to find the relationship between x and y. So that's gradient of AP times gradient of BP equals -1. Okay, so what's the gradient of AP? Gradient of AP is y minus 3 over x minus 5. So multiply by the gradient of BP, which is y plus 2 over x minus 4, and this one is equal to -1. So the product of the gradients of the perpendicular lines equals to -1. Okay, so if we simplify the top expressions, we get that's y squared plus 2y minus 3y minus 6 over, and now we simplify the denominators, we get x squared minus 4x minus 5x plus 20, okay, equals to -1. Now we want to collect like terms on our numerator, so we get y squared plus 2y minus 3y, you get minus y, okay, minus 6. And then we want to collect like terms on our denominator, we get x squared minus 9x plus 20 equals to -1. And here we cross multiply. We want to multiply x squared minus 9x plus 20 with -1. So finally we get y squared minus y minus 6 equals to -1 times x squared, you get minus x squared, minus 1 times minus 9x, you get plus 9x, minus 1 multiplied by 20, we get minus 20. Okay, remember we are looking for the relationship between x and y, so I'm going to take all the terms on the right hand side of the equal sign to the left side. Okay, so this one, when you switch to the left, changes the sign and it becomes positive. So I will have x squared plus this y squared. Okay, this one becomes minus 9x followed by this minus y. Then minus 6 plus 20. Because 20, when you take it to the left hand side, changes the sign, becomes positive, equals to 0. Then we simplify here. So finally, the relationship between x and y is x squared plus y squared minus 9x minus y minus 6 plus 20 is plus 14 equals to 0. Okay, so this is the relationship between x and y. Okay guys, thank you for watching. See you in the next videos.